What Zach asked me to talk to you today about is greenhouse design. And it's always interesting because I have never taken a course in greenhouse management. But I've been teaching it since 1985, so I guess you learn by teaching. And one of the things that this class is focusing on is sustainable landscape, sustainable design, and I can speak English. Anyway, so one of the first things that when I talk to a group, and I talk to different groups all the time about building a greenhouse, business, and we're typically focusing more in this class on residential properties. So I'm going to blend a little bit of commercial and residential together. And this first slide is actually the issues. If you can solve all these issues on this slide, you'll be a successful greenhouse owner. Most of our greenhouse property owners throughout the United States and throughout the rest of the world, primarily in Europe, greenhouse owners that are fairly wealthy, they're wealthy because they built their greenhouse operation out in the country and now they've been urbanized. The city has enclosed them. The sprawl has become around them, and their property values have gone up, and these sorts of things, along with the taxation. And most greenhouse operations that have been established in a location for a long time have been grandfathered into a tax base based on agricultural production. So when you start looking at building structures, you have to think about what is the climate going to be like on the property that I'm building my greenhouse today, and what's it going to be like tomorrow, 5 years from now, 10 years from now. Tax base. What is the taxation? I just completed a pretty nice deck and pergola on my house. I went through all the zoning requirements and all the permitting requirements, and my taxes went up $300 a year. But I improved the value of my property by almost $15,000 for a $5,000 investment. So you're going to have to do taxes. Residential greenhouse owners have to deal with zoning ordinances. Can you put a greenhouse on your property? Does your homeowner association allow an outbuilding? Does it have to be architecturally approved? If you're moving into Old Town, if you're going to put a greenhouse on the side of your building, you might have to go through the Historical Society. There are some older homes, some older small bungalows in the Old Town area that actually have old chicken coops that go back to the turn of the century. And if you want to convert that to a greenhouse, you have to get historical approval because the building was built before 1950. So you need to think about the zoning. What kinds of codes do you have to have? Because oftentimes a greenhouse sometimes is considered to be a temporary structure. Like if it's just a conduit frame with some poly stretched over it, is that a structure? Most zoning codes, it is not a structure. It's a temporary structure. However, the homeowner association may not allow it. So you have to spend a lot of time thinking about zoning and those requirements. If you're a greenhouse owner, commercial operation, you have to think about where you're going to build your operation. Like a lot of our greenhouses are now in areas that's called light industrial. They maybe have an ag-based taxation, but they're zoned light industrial. Can you go in and build a commercial greenhouse in the middle of the city? Not likely. Okay? Fire codes. Some of our greenhouse materials are somewhat flammable. Some are not. What do you have to do to meet the fire code standards? Setbacks and easements. In Fort Collins, if you build a storage shed on your property without a permit, you've got to be at least 5 feet back from the property line. Some parts of the country, in the East Coast, it's 8 feet. If you encroach on that, you have to have a firewall, which is gypsum. Drywall doesn't transmit light very well. So you need to think about what kind of setbacks and easements do you have to worry with. I helped place a greenhouse at Boulder Valley Tech School, which is a vocational high school on Arapahoe Road, and it's right across the street from a power plant. And it had to be so many feet away from the building, and it couldn't be under the power lines that ran across the street. If you go and look at that greenhouse where it's situated, it's at such a screwy angle. You say, who on this planet figured out why to put it at that screwy angle? Well, it was me, because I had to fit it along the easement and think about the setback from the building. So these are all things you need to think about when you're building a greenhouse or building any kind of structure at all in your landscape. Yes, question. What I would think, the setback I was talking about is 5 feet away from the property line. 5 feet from the property line. Some communities it's 8 feet. In the West, it's 5 feet. So these are kinds of things that you need to think about, and we haven't even gotten to the horticulture part. We're just now talking about getting it through a permitting process, building process, and these sorts of things. Next thing I need to think about is microclimate. Do I have to deal with fog, topographic shadows? I bought a new home 6 years ago, and my wife refused to let us look at a property that the driveway did not face south. I'm here to tell you now that I very much appreciate that, because I don't have to shovel the sidewalks nearly as much as my neighbors, because the southern face, and I'm taking full advantage of the sun. Topographic shadows. How close are you going to put the greenhouse to a building? You're not going to put it on the north side, because in wintertime, you're not going to get any sun. And you need to think about winds and wind tunnels. The wind never blows in Colorado, right? So we need to think about these sorts of things. And microclimates is pretty much something we need to think about, especially for residential greenhouses. Cold air pockets, frost pockets, can give us problems. How many of you have driven to Denver on a cold, clear, blue morning, below zero, drop into the St. Vrain Valley, and all of a sudden have zero visibility? That's interesting. Why is my computer asking me to log into Facebook? I don't understand that at all. Okay, so cold air will accumulate in pockets, like the St. Vrain Valley, the Thompson River Valley. Those are cold air pockets. Some properties where the cold air falls, you're going to run into problems. Atmospheric pollutants, close to, for instance, there's a greenhouse operation just off of the I-76 in the Commerce City area, and they're right at the base of a on-ramp of the interstate, and I don't know why this is happening. Zach loves it when the geeky guy gets slammed. Yeah. Topographic shadows is probably what we need to think about. Your trees, and we're going to talk a little bit about solar altitude here in a few minutes, and you want to think about areas of wind acceleration, the Venturi effect. Of course, we don't have carburetors on our cars anymore, so a lot of people don't know what a Venturi is, but it's basically a constriction of airflow where it speeds the air up. And, of course, hail. So one of the biggest issues people think about is when they put a greenhouse on a property, whether it's a residential operation or whether it's commercial, is Facebook. So we want to maximize the amount of light that we get into our greenhouse during the period of the year when the light is limited. And when is that? Frankie? Wintertime, okay. And we do that, we want to maximize light. We orient our greenhouse angle, or what we call the angle of incidence. And that angle of incidence is the angle that a light ray striking the surface makes with a line perpendicular to the surface. In other words, we want an angle of incidence of 0, which is perfect. We're going to get as maximum amount of light. Because we want to cut down on what's known as reflective loss. Because reflected light is lost light. Okay? So where does that come into play? How it changes if you orient your ridge line north to south. Your midsummer transmission is 64%. Your midwinter transmission is 48% light. East to west, now this is 50 degrees north latitude. Who knows where 50 degrees north latitude is? Anybody? No, not Boulder. Boulder is 40 degrees, is not approximate. Baseline highway, Highway 7, is 40 degrees north latitude. Okay? So that's kind of our magic line. So east-west orientation, we can do at higher latitudes, we can increase our transmittance. So this is the light that comes in our greenhouse. Sun up here to the right, beaming down on our surface. Okay? We have light that's transmitted. We call that direct transmission. We have diffuse transmission. That's light that's been scattered. Okay? A portrait photographer uses a diffusion filter to scatter the light so it takes the shadows off of the portrait face. Okay? Then we have reflected transmission. A reflected light is not in the greenhouse. And then we have absorbed energy. Electromagnetic waves are absorbed, and that's converted into heat. So this is where our light goes in. So above 40 degrees north latitude, most greenhouses, we orient them east-west. Okay? Below 40 degrees latitude, this is north or south, it doesn't matter, we orient them north-south. So here you can see that winter at a high latitude, above 40 degrees latitude, and we're just a little above 40 here, you can see that the angle of incidence is going to be wider in the midwinter. Therefore, we're going to have high light reflection. Below, we have better light transmission, and we have a much shallower, not quite as extreme angle of incidence. So here's a picture of our greenhouses on Lake Street, and you can see that in the late sun, you see that all that reflected energy? That is lost light. That is lost light. And in the winter months, when it's so dark and dismal, and we're trying to grow something in a greenhouse, we're trying to maximize that light into the house, we need to think about this angle of incidence. So how do you determine that? Well, we can calculate what's called the azimuth, the solar azimuth. And the solar azimuth that we typically are going to schedule is on the 21st of December, which is the winter solstice, within a day or two, depending on which leap year it is. Okay? So this is done at 49 degrees north latitude, and this is actually the Canadian border at the Montana line. Okay? Give you a perspective. So 21st, our solar angle is here. And I grew up in southwestern Montana, and I remember around just before Christmas break, we would go to school on the bus in the dark and come home from school on the bus in the dark. Okay? You think the days are short here? Try a little further north. So we want to orient our glass, our glazing material, to be perpendicular to that solar azimuth. And that increases, that single design perspective increases the amount of energy coming into your greenhouse by magnitudes of 10, 20, 30 times. So that's part of the take-home measure I want you to take home from here. Now, in the summertime, 21st of June, I'm not so worried about all that light because we got lots of light. And it's beaming down, it's hot, and I'm going to actually screen that out. So a lot of residential greenhouse operations will actually put an opaque surface, and they will put that perpendicular to the angle of incidence, or right angle of incidence of 0, perpendicular to the light rays coming in, as shading. So when you go around and look at building designs, especially the new chemistry building over here, you'll see they've got little frames built on the outside of the window. Those are actually set and extend out at a certain angle to provide some cooling and to reduce the amount of heat energy coming into that window during the heat of the summer. That's part of green building design. Right? Okay. Zach has to remind me that I'm a plant physiologist and a plant nerd, not a construction guy. So it's all about orientation. So here we've got winter sun and summer sun. What's important to remember is that the sun moves across the sky every day. Or is it the earth moves under the sun, across, giving us the appearance of moving. So what I want to do, not only do I want to maximize the amount of light and reduce the amount of reflected light, is I want to make sure that that shadow moves across my greenhouse every day. I don't want the shadow to sit in one place. That north-south orientation with the ridge line going north and south, we're going to get, that ridge line shadow is going to move all day long. If it's oriented east-west, that shadow is going to stay in one place all day long. Commonly designed greenhouses in northern latitudes, we do build them east-west, and we orient them in such a way to maximize the winter sun and orient our plant benches and our plant arrangements in such a way that we don't have to worry about that stationary shadow. Okay. So these little areas we typically think of as poor locations. Actually, if you read hobby greenhouse design handbooks for this part of the country, we usually recommend an eastern exposure rather than a western exposure, thinking about the intensity of the summer sun. Remember what the tourism board for Colorado says about Colorado is that we have how many days of sunshine a year? 300. Okay, so we all have to think about everything. So a lot of people will orient either on the southern exposure or the eastern exposure, because western exposure is way too hot. And we want to avoid the northern exposures. I have snow in my backyard that's been there since the first snowstorm on the northern exposure of my home. So you need to think about how that happens. Yeah.
Can you explain why you oriented east-west?
Okay.
Above or north 40 degrees?
Angle of incidence is shallower in wintertime. And the sun is going to be moving across the face of the greenhouse like this. Okay? So I'm trying to maintain that angle of incidence the same all day long. Where if I do it like this, I eliminate the shadow as it comes across, but since we have a pitched roof here and a pitched roof here on the right and left side, we're going to have a changing angle of incidence all day long. So we're focusing on north of 40 degrees north latitude. We want to capitalize on keeping the angle of incidence the same. South, we capitalize on this, it's not such an issue. That make sense? Okay. It's part of site selection and design. I think you talk about that a little bit. Okay. So most greenhouse configurations for residential are typically what we call a lean-to. institutional hobby greenhouses. This is the greenhouse at Montana State University in Bozeman, Montana, fairly north of us. This is the southern exposure. This is the main building. This angle pitch is designed for maximum angle of incidence. This is a small lifestyle farm in Paonia, Colorado. They've got glass on the side, and then they've got fiberglass on the roof. And actually under the roof they've got insulation, and they're primarily focusing on maintaining good light in the wintertime. And they grow lettuce in that greenhouse. Conventional greenhouse, the 6x12 pitch, is what we call an even span. 6x12 refers to the rise over the run ratio. Uneven span greenhouses are oftentimes used for properties that are on a slope. However, this is also a design that's used relatively commonly in high latitude zones, where this is the clear light transmission and this is the solid opaque material for insulation, and they'll run this ridge line east-west. And commercial operations, we do what we call ridge and furrow or gutter connect, hoop quonsets or barrel vaults, quonset huts. The word quonset actually comes from an area of where a plant was established called in Quonset, Rhode Island. The Quonset design was originally put together during World War II, where the Navy needed a building that could be quickly erected by low-skilled labor, sailors, to erect buildings in the South Pacific quickly, cheaply, and inexpensively. And I have personally erected Quonset greenhouses by myself, so they're pretty easy to build. So inexpensive. However, most zoning ordinances do not allow Quonset buildings. So some frame profiles. There's nothing magic about building a greenhouse. They're basically a pole barn with a clear roof. We have the traditional 6x12 design, which is the high profile design. And then we have the 2x6 profile, low profile, which is more common in Northern Europe. The low profile actually has, because of the geometry of the roof, has a lower surface area exposed, therefore it's cheaper to heat. That's why they choose that design. Quonset huts, film plastic, temporary structures. Probably over spring break I'll be building a little Quonset hut in my backyard just so I can beat my neighbors on their tomatoes. So. But I don't have a homeowners association that really cares what I do. Double layer poly, we inflate it with air to keep it tight like a down coat, using squirrel cage fans and such as that. What I'm going to build in my backyard is for a small Quonset is basically going to be about 10 feet wide by about 7 or 8 feet high, with a sheet of poly stretched over it. I'll build it out of poly PVC pipe and stretch the plastic as tight as I can so the wind doesn't rip it apart. I'll be doing it as cheap as I can. So. And you can build much smaller greenhouses. Oh yeah. That are 2 or 3 feet across by. I typically call that a cloche. Or Frank Stonecker was last week. Did he bring any information on high tunnels? Okay. Whenever I talk about greenhouse, everybody says, okay, I want to have a solar greenhouse. Well, let me tell you something. A greenhouse is a solar collector already. That's what it is. But solar panels can be beneficial. You can use and I'm going to get into some slides here in a minute where I'm going to show you how to use the energy that a greenhouse brings in the wintertime to help heat your home. These are liquid transfer solar panels. This one is glycol based. It circulates hot glycol. This is basically they have a vent up in the roof of the greenhouse, up in the gable. They suck that hot air down and they pipe it under the lettuce beds. Works pretty well. This is another greenhouse, solar operation greenhouse. And just to show you that this is nothing new, this is one of my first greenhouse projects I did, solar projects, in 1986. So, solar technology is nothing that new. So, anyway, so it's all about heat. That's one of the biggest things. That's one of the biggest expenses of having a greenhouse is the heat. Keeping it cool in the summer, keeping it warm in the winter. So we can do all kinds of solar gain projects where we can take the heat out of the roof and put it underground. Ground source heat pumps. Everybody thinks that's the way to go, ground source heat pumps. The problem with ground source heat pumps is to get enough BTUs out of the ground to keep our greenhouse warm, we have to punch too many holes. And it becomes cost prohibitive. Actually, the payback on most ground source heat pumps for a greenhouse is 25 years. So that's not very sustainable. This is why people still burn fossil fuels, because fossil fuels are still relatively cheap. Here's another greenhouse solar thermal design structure that's being used. It's being considered. This is what we call a slinky coil system, where we just dig trenches in the ground and we bury the pipe and we have a heat exchanger up in the roof of the greenhouse. This is probably the design technology that's going to have the most merit over time. Hot water systems. Some stuff we're working on at CSU includes phase change gels. This is a greenhouse design where they've gone in and trenched into the ground in a small greenhouse operation. Some plastic ducting. They've insulated the foundation. This is Scott Scoverbow's home. Okay? You can say you saw Scott's greenhouse. He's about this tall. But underneath this gravel are those air circulation pumps, and draw in the hot air here, this point, and distribute the air out of the ground at this point. So there are some technologies that are working. Phase change salts is an area that we're currently working on. A lot of greenhouses will use barrels of water as a storage reservoir for their heat, because the water heats up during the daytime and then gives off the heat back in the evening. But to have that same volume of heat exchange capacity, a 55-gallon drum gets kind of big and cumbersome, whereas in these steel pipes, each one of these steel pipes with a phase change gel, and you know what I mean by phase change? Okay. Phase change. How many phases of matter are there? How many? 5?
Yeah, it include superliquids and plasmas.
Okay. So what are the ones that most people think about?
Solid, liquid, and gas.
Solid, liquid, and gas. Okay. So I've got some people in the class that have had my class before. So when we go from a vapor phase to a liquid phase, or go from a liquid phase to a solid phase, there's an exchange of energy called a phase change. So when it goes from what these phase change gels do is, as water gives off heat, it's a nice smooth curve. Okay? Whereas we put these phase change salts, and they go from solid to liquid, you can see they have little exotherms as it gives off the energy, and it's a more efficient means to store heat. A road trip you should consider doing, if you want to see a fully solar-powered greenhouse, is at the Cheyenne Botanical Garden. They have a greenhouse there that's fully powered both with photovoltaics and with battery systems, as well as phase change materials. Okay. All right. So what are some construction and design ideas you can use for your greenhouse design? I've got a series of images that I'm going to show you, and I want you to think of these all being perpendicular to the angle of incidence and on the southern exposure. 10 foot by 16 foot width is pretty reasonable for a typical residential type greenhouse. We like it to be 1.5 to 2 times its width in length to have a good volume of air, so we don't have a lot of extremes in temperature. The smaller the room, the spikier the temperatures. If you have a very small bedroom, you know it's either hot or cold, right? It's hard to get it just right. So a little bit of a volume. You have to have a foundation. And most people will do something like a poured concrete piers, caisson, or something like that. If you use wood, it has to be treated wood. And you wanted to have it below the frost line in Fort Collins. That frost line is 42 inches, I believe, by code.
Yeah, well, the city will let you do 30 inches.
They'll let you do 30? It didn't let me do 30. Okay. So you want to have some kind of a structure. You need to have a floor. Now, a couple things to think about. If you do a brick or stone and you let the water leach through, you're not going to have standing water in your greenhouse. But if you're using lots of fertilizers and you let it leach through, you're going to contaminate the groundwater. What are we going to do? Well, try to be as clean as possible. If it's a solid floor, you have to have drain. If it's drain and you're following the code, are you going to have to can you put that into your environment, or you have to put it in sanitary sewer? Depends on the zoning ordinance of your community. What is it here, Zach? Do you know?
In here, I believe you have to drain it in sanitary sewer, and then you have to get a special permit, and you would end up paying twice for your sanitary.
That's right. So you get into these sorts of things. So we want to put a weed fabric, want to insulate it, want to make sure you got drainage and so forth. Typically, we're going to orient this east to west with a southern exposure, do some solid cover to reduce heat loss, and the rest of it glazed or partly glazed. And what I'm doing here is I've got a pair of vents that go into the building. I want to take the hot air into the building and the cool air out of the building, and I want to build a recirculation system. Now, you can buy technologies, fan technologies, that will boost the air. This will do this naturally, somewhat, on a day-to-day basis, through the adiabatic differences in temperature. Okay, but if we put a booster, and what we do is we'll have a thermostat device that measures the temperature in the greenhouse. When the greenhouse is warmer than the temperature on the inside of the house, that pressure differential will turn the fans on and circulate the air. And that's a standard system that a lot of residential greenhouse builders will do to take advantage of all of this energy that's being collected here. Now, we can line this wall with jugs of water as a heat sink. You can buy phase change tubes that you could put on here as a heat sink. All kinds of different things out there. At nighttime, all of a sudden, the whole world is reversed. A couple things you can do to prevent the heat loss at nighttime is you can have shade curtains that drop down, which is probably the most efficient, or you can just shut it off and hope it stays there. So we need our glazing. We want to maximize the amount of energy when the light level is the lowest. And we can take advantage of this only partly opening this particular section here in our residential design to maximize or allow some light during the summer months, and I'm going to shade a good portion. Now, the other thing, this too, is typically we want to have a solid surface under the eave of the home, because the eave of the home typically is going to come out about 15 inches, and I don't want snow and ice falling off that into my glazing. it gets kind of fragile, especially if you're using glass or something like that. So there's different kinds of greenhouse designs that you can have. This particular design, you can see the solar gain, winter versus summer. Another design, winter versus summer. Another design. So there's different kinds of structures you can use to maximize your light intensity and reduce your winter heat stress. Your summer heat stress. Because in the summertime, we don't want this greenhouse to become a heat load that's going to raise our electric bill, cause us to have more air conditioning requirements. Okay? So this particular one, maximum headroom, lowest summer heat load, but the lowest winter solar gain. So when you're designing a residential property, a residential greenhouse, you need to think about how can I maximize the light into my greenhouse when I need it the most, and how can I reduce the heat load when I don't want it. That's the conundrum. And frankly, for our area, this particular design is going to be the most effective. Is there a name for that specific one? I don't know. I've never seen a name. It's just a lean-to configuration.
Is there like a percentage that we could write down, like to specify?
I don't know. So. You haven't changed, have you? The other thing, when you get into these sorts of designs, the more angles you create on something, every time you do a new angle, you increase the complexity of your design. And Zach will tell you that I'm a glutton for punishment. He's seen my deck. Glazing. Glass is typically the most appealing, has the longest service life. It's going to give us best long-term strength. It's going to require more structure because it's heavier. You should consider tempered glass. Most commercial greenhouse operations use storefront plate glass, which is supposedly strong enough to withstand a beer bottle being slung at it. And tempered glass in Colorado will withstand, 3/8 inch tempered glass will withstand a hailstone of about the size of a softball. Other materials, translucent polymers, fiberglass reinforced plastic, polycarbonates, they actually have higher light transmission levels. They're lighter, they're cheaper, but oftentimes they don't fit within zoning ordinances. Fiberglass reinforced plastic, the fibers over time will bloom or shred out and collect dirt and gather debris. So. Pros and cons. Glass, aesthetically pleasing. You can get double wall. Every time the Garden and Home Show happens, I get phone calls from people thinking, I want to get low E glass. Is that going to interrupt my plant growth? Plants use visible light, except for green light. Plants don't use any green light because they reflect it. Okay? I don't care about the UV light. Plants don't use UV light. So the double wall glass, the only thing it does is reduce light transmission. More framing, more shadows. Plastics, they're lighter. Make sure that you buy greenhouse quality polymers that you use because they have UV protectants built into them to make them last longer in the environment. Rigid plastics, they're cheaper, easy to install, they don't require a lot of sophisticated technology, so forth. Okay. You have a question? Yes, sir. I'm sorry. Say that? Okay. I'm not familiar with that technology. I've read about it where you have the light changes in this transmission, okay, based on electrical signal. I think maybe someday when it's not cost per, that's pretty expensive. That'd be cool. I'm sure there are technologies that are coming on that we'll see as more and more things happen and things become more fashionable. One of the things about greenhouse technology in the United States, if you compare greenhouse technology in the United States to greenhouse technology in Northern Europe, you'll think that we're light years behind Northern Europe. And in fact, we are. You know, they're building their greenhouses vertically, and we're building our greenhouses horizontally. Why? Is that because we're just arrogant Americans? Well, could be we're arrogant Americans. How long have the Northern Europeans been living next to each other? Thousands upon thousands of years. I mean, there's some families living in homes that their great-grandparents built. They've run out of room. We have lots of room. We have lots of cheap fuel. We waste it. Food in the United States is cheap. We use less of our money to buy food in the United States than any other country. Let me rephrase it. We use less of our discretionary income to buy food. It's cheap. So we don't build these high technology facilities. When food gets expensive, then those technologies become relevant. So, what is a vertical greenhouse? A greenhouse is basically, well, a lean-to greenhouse is basically a vertical greenhouse, but it's floor upon floor upon floor upon floor.